Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video I told you about the different OPAMP characteristics such as the input offset voltage, output offset voltage, input offset current, input bias current, CMRR, SVRR, all these things we covered in the previous video. So in this video what we'll do is we'll take a look at some of the problems that can be framed based on these characteristics. So let us start with the first problem. It says the voltage transfer characteristic of an OPAMP is shown in the figure. We need to find the value of gain and the offset voltage. When it says offset voltage, we will find out the input offset voltage. Now what was input offset voltage? It was input voltage at which V0 is 0, or you can say x-axis intercept of characteristics. We need to find the x-axis intercept. As you can see in the graph, what is the x-axis intercept here? The x-axis intercept is 1 millivolt. Now we want to find the gain. The gain is always determined in the linear region. From here the slope will be equal to gain. So what should be the value of gain? It should be delta V0 by delta Vin. So what is the change in Vin? 1 millivolt. What is the change in V0? That is 5 volt. So it will come out to be 5000. Take care that V0 here is in volt and Vin is in millivolt, so that when you are putting the value to find out the value of slope, you have to take care of the units of the voltage, that is volt and millivolt. Next, in the following circuit, the OPAMP is ideal, but it has an input offset voltage of 2 millivolt. Find the output voltage. Now in such cases, what you have to do is, when you are given the input offset voltage, this is the circuit, I am redrawing the circuit. This is 60 millivolt. Okay. You will connect the input offset voltage as a source at the positive terminal. So this source will be 2 millivolt. Always remember, connect VIO as a source at non-inverting terminal. Okay, that we always have to do. Now, this is 6 kilo ohm, this is 1.5 kilo ohm. We don't know open loop gain, so I'll assume that the open loop gain tends to infinity. Whenever open loop gain tends to infinity, what we can use? We can use the concept of virtual ground. By virtual ground, what I can say is positive and the negative terminal voltage must be same. So what is the voltage at the positive terminal? It is 2 millivolt. So voltage at negative terminal should also be 2 millivolt. The voltage here is 2 millivolt. Now find this current I. I in this circuit will be 60 minus 2 by 1.5 kilo ohm. 58 by 1.5 kilo ohm. Now this current does not enter the OPAMP because we know the internal current to OPAMP or the input current is 0. So where will this current go? this current will go here. So what is the other equation of I? This voltage is 2 millivolt. Here it is V naught. 2 minus V naught by 6. This should be 58 over 1.5. So this will become 4. So 2 minus V naught is 232, or you can say V naught is minus 230 millivolt. Okay. So remember, whenever you know the input offset voltage, always connect a source which is equal to the input offset voltage at the non-inverting terminal. Moving on. In the circuit shown below, the input offset voltage and input offset current are 4 millivolt and 150 nano ampere. We need to find the total output offset voltage. That is the output offset voltage due to two things. One is the input offset voltage and the other is the input offset current. Okay. So remember, whenever we talk about input offset voltage, we connect a source. We connect a source at the non-inverting terminal. So we will show a source like this. What about the input voltage? See, in previous question it was asking us the output voltage. It was not asking us the output offset voltage. It was asking us the output voltage. That is why I considered the input voltage as well as the offset voltage. But in this question it is asking the output offset voltage. So when it is asking the output offset voltage, you will not consider the input voltage but only the input offset voltage. So I will ground this Vi, because when we are talking about output offset voltage, it is V naught when Vi is 0. So output offset voltage is nothing but the output voltage when there is no input. Okay. So this is 5 kilo ohm. This is 500 kilo ohm. I have not yet considered the input offset current, so I will make use of superposition. So I will first find V naught 1. Now we very well know that the input current to the OPAMP is 0 ampere. If the current is 0, the voltage drop across 5 kilo ohm is 0. So what is the voltage here? 4 millivolt. If you consider that the open loop gain is infinite, you will always consider open loop gain to be infinite unless open loop gain is separately given. So I am assuming open loop gain is infinite. So I can apply virtual ground. If I apply virtual ground, the voltage here will also be 4 millivolt. So what will be this current I? This current I will be 4 millivolt minus 0 by 5 kilo ohm, or you can say 4 by 5 microampere. Now since the current at the input terminal of OPAMP is 0, this current I will go like this. Okay. So now what will be this equation of I? I is flowing between these two terminals. So you will say V naught 1 minus 4 millivolt by 500 kilo ohm is also equal to I. 4 by 5 microampere. This is 100 kilo. 100 kilo means 10 to the power 5. So 4 micro into 100 kilo. So V naught 1 will become 404 millivolt. That is the output offset voltage due to input offset voltage. But we also know the input offset current. So in the next circuit, what I will do is I will remove this input offset voltage and I will only consider the input offset current. So this terminal will be grounded. Okay. Now what I will do is, see this. This current is 0 ampere. So the voltage here is 0 volt. It will be grounded. The voltage here will also be 0 volt. How do we show the input offset current? We show like this. That is, it is flowing between input and the output terminal. So this current I that we showed earlier, this I will now be input offset current, which is equal to 150 nanoampere. So you have to show input offset current leaving the output terminal and entering the input terminal. So this is 0 volt. So now this will be called as V02. How you will write I? V02 minus 0 by 500 kilo ohm equal to 150 nano ampere. So V02 will be 150 into 500 microvolt. So or 500 into 0.15 millivolt. So that is 75 millivolt. Now we have two voltages, V01 and V02. I will say output offset voltage is the sum of both. I am using superposition theorem. That is 479 millivolt. So remember, when input offset voltage is given, you connect a source at the non-inverting terminal, and when input offset current is given, you consider current flowing in a loop between the output and the input terminal. Next problem. In the circuit shown, each amplifier has a offset voltage of 10 millivolt, that is input offset voltage. We need to find output voltage. Now see the first amplifier. We have given an input voltage of 10 millivolt. This is not input offset voltage. This is the input voltage. Coincidentally, the input offset voltage is also 10 millivolt. So what we will do? We will connect a 10 millivolt additionally at the non-inverting terminal. So what is this total voltage? This total voltage is 20 millivolt. Now consider, since open loop gain is not given, consider it to be infinite and it has negative feedback. So that means I can apply virtual ground. If we apply virtual ground, the negative terminal voltage is equal to positive terminal voltage, which is 20 millivolt. So the voltage here is 20 millivolt. If this current is I, there is no current in the non-inverting terminal, this current should also be I. So how you will write I? I can have two equations like 20 millivolt minus 0 by 10 kilo ohm. That is the current in this resistance. This resistance current is also I. V01 minus 20 by 100. So V01 is 220 millivolt. Now we know the value of V01. In this circuit also you will connect a source of 10 millivolt because that is your input offset voltage. Again, if you assume that open loop gain is infinite and it has negative feedback, we will apply virtual ground. By virtual ground you can say the negative and the positive terminal voltage both are 10 millivolt. So this voltage is 10 millivolt. So suppose this current is I1. No current enters the input terminal. This current will also be I1. So I1 will have two equations, V01 minus 10 by 10k and the other 10 minus V02 by 50k. So it will be 5. 5 V01 minus 50 is equal to 10 minus V02. So V02 is 60 minus 5 V01. V01 is 220 into 5, 1100 minus 1040 millivolt. Okay. So that will be your output voltage, that is 1040 millivolt. Is it fine? So the voltage V in is the input voltage. It is not the offset voltage. Offset voltage will never be connected in the circuit. You will have to connect that manually at the non-inverting terminal. Moving to the next problem, it is based on slew rate. In the circuit shown below, the OPAMP slew rate is 0.5 volt per microsecond. If the amplitude of input signal is 0.02 volt, find the maximum input frequency that can be used. Okay. See, first of all, since open loop gain is not given, I will assume it to be infinite. Due to negative feedback and infinite open loop gain, I can apply virtual ground. Once I know this, I know that positive and negative terminal voltages both will be 0. Because positive terminal voltage is 0, so negative voltage will also be 0. If this current is I, this current will also be I, because we don't have any current at the input terminal. So I will be Vi minus 0 by 10k. 0 minus V0 by 240k. So V0 will be minus 24 Vi. Now it says amplitude of input signal is 0.02 volt. 0.02 sine omega t. Okay. When signal is not given, you will assume sinusoidal signal. So it will be sine omega t minus 0.48 sine omega t. Now I told you slew rate is dV0 by dt maximum value. So take the derivative, minus 0.48 omega cos omega t. For maximum value, you will keep cos equal to minus 1. Minus minus will be plus 1. 0.48 omega. Now this should be less than slew rate of the OPAMP, 0.5 volt per microsecond. From here we can calculate the frequency. Okay. So from here omega is less than 0.5 into 10 to the power 6 by 0.48, or you can say frequency is less than 0.5 into 10 to the power 6 by 2 pi into 0.48. Why I am taking 10 to the power 6? Because microsecond is 10 to the power minus 6. So this value you can calculate. If the units of frequency is not given, you will find in hertz. If units was given, we could have found in radian per second. Okay. So that is how you have to use the slew rate. Next question. The OPAMP shown in the figure has a slew rate 1 volt per nanosecond. What is the highest input frequency at which no slewing occurs? Now see, this is negative feedback and open loop gain is not given, so I'll assume it tends to infinity. That means I can apply virtual ground. If I apply virtual ground, the positive and the negative terminal voltage both will be equal and they will be equal to 0.5 sine omega t. Now this voltage will be 0.5 sine omega t. What is this current I? I will be 0.5 sine omega t minus 0 by 1k. That means 0.5 sine omega t milliampere. Since there is no current at the input terminal, this current will also be I. So now what is I? V0 minus, what is the voltage of this terminal? 0.5 sine omega t by 3 kilo ohm. 0.5 sine omega t milliampere. Take this on the right hand side. When you take it on the right hand side, milli and kilo will get cancelled. V0 minus 0.5 sine omega t equal to 1.5 sine omega t. So V0 is 2 sine omega t. Now for slew rate, dV0 by dt will be 2 omega cos omega t. So for slew rate we need to take maximum value, it will be 2 omega. It should be less than or equal to 1 volt per nanosecond. So omega should be less than 10 to the power 9 by 2. Or you can say 0.5 giga radian per second. Okay. So that should be the maximum value of omega. So at this frequency there will be no slewing that will occur. And what you have to do for f For f, you will divide it by a factor of 2 pi. So always check the units in which your answer is asked, and based on the units you will give the correct answer. Moving to the next problem, it says an audio amplifier is designed to have a small signal bandwidth 20 kHz. The open loop low frequency voltage gain is 10 to the power 5. Unity gain bandwidth is 1 MHz. Find maximum closed loop gain. Now for OPAMP also we know one thing, that gain into bandwidth is constant. Now what is unity gain frequency? At unity gain frequency Ft, the gain becomes equal to 1. So 1 into Ft is constant. That means what is the constant value? It is Ft. So gain into 20 kilohertz is equal to Ft. So what should be the closed loop gain? Ft is 1 megahertz by 20 kilohertz. So it will come out to be 50. Okay. So always remember, the product of gain and bandwidth is always equal to the unity gain frequency. Next problem. An open loop OPAMP, okay, has a gain bandwidth product of 1 megahertz. Non-inverting amplifier using this OPAMP will exhibit a voltage gain of 20 dB and a 3 dB bandwidth of. So here we know the product of gain into bandwidth. The product of gain bandwidth is 1 megahertz or 10 to the power 6. Now this gain is given as 20 dB. In dB the gain is 20 log on a base of 10 magnitude of gain. That means mod of gain is equal to 10. So what should be the bandwidth? 10 to the power 6 by 10, or you can say 100 kilohertz. Don't get afraid by seeing this 3 dB bandwidth. The bandwidth is always defined at 3 dB. So it is giving us a gain and it is asking us the bandwidth. Don't get confused by seeing this term 3 dB. Okay. Next question. An amplifier using an OPAMP having a slew rate of 1 volt per microsecond, gain of 40 dB. If this amplifier has to faithfully amplify sinusoidal signal from DC to 20 kHz without distortion, the input signal should not exceed. So it is asking the maximum value of input voltage. Whenever you see the slew rate, always remember the slew rate of output should be less than slew rate of OPAMP. Okay. That is dV0 by dt maximum should be less than slew rate of OPAMP. Now the gain of this amplifier is given to me as 40 dB. In dB the gain is written as 20 log on a base of 10 magnitude of gain. That is 2. So 10 to the power 2 is mod of gain. So what is magnitude of gain? It is 100. That means V0 is 100 Vin. Or you can say V0 is 100 Vm sin omega t. So if you take dV0 by dt, what it will be? 100 omega Vm cos omega t. What should be the maximum value of dV0 by dt? For that, cos must be 1. 100 omega Vm. This should be less than 1 volt per microsecond. So 100 omega Vm should be less than 10 to the power 6, or Vm should be less than 10 to the power 4 by omega. So what is the omega maximum value? 20 kilohertz. So it is 2 pi into 20 into 10 to the power 3. So that is 1 by 4 pi. So 1 by 4 pi is 79.6 millivolt. So that is the maximum value of the input signal, that is 79.6 millivolt. The input signal should never exceed this value. Is it fine? So we have seen there are mainly two type of question that can be asked on the characteristics. First are based on the input offset voltage and input offset current, and the second one are based on slew rate. Okay. So now I hope this kind of question you can solve easily. Thank you.
So for 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil, and Telugu, JEE channel, Computer Science, Gate Question, and Electrical Junction, Pathshala, and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like, and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon, so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.